Welcome back, everyone. In this video, we're going to look at solving basic inequalities. Let's start with some good news. So far, we've looked at inequality statements that have already been solved. Yay, that was pretty easy. But now we need to look at how to solve an inequality, and the good news is that the statements for inequalities and how to solve them is almost the same as solving equations, with one big exception. Whenever you multiply or divide by a negative, you have to flip the inequality over. So let's start with a statement like this to emphasize this small difference. We have negative 4x is less than 20, and we need to figure out what value of x would make this statement true. Now, if we were to pick 5, let's just say we picked 5 here. Positive 5. That would make this statement say negative 4 times 5 is less than 20. Is that a true statement? Well, that would be negative 20 is less than 20. That is true. What if we were to pick negative 5 instead, and we said negative 4 times x, but in place of the x we put a negative 5, is less than 20. This is where it gets kind of weird. Would we have a positive or negative 20 on the left? Well, we'd have a positive 20 is less than 20, and 20 is not less than 20. That is not a true statement. So we have to think about where that 20 would sit. Well, we have 20 here on the number line. I drew that earlier. And we want anything less than 20. So then we have to figure out what numbers for x would make that true. And we've already looked at what happens if we put a negative 5 in there. So let's make this 0, and let's go ahead and make these increments of 5. And now let's think about what we've done. We just found out that if we put negative 5 in, the actual value of negative 5 in, we will have something that's not true. But 5 worked, so I'm going to just go ahead and put a little green mark there at 5. 5 was good. Negative 5 was not so good. That didn't work. Let's go ahead and put something else in there. Let's put 0 in. Let's try 0. If we put 0 times negative 4, that would give us 0 is less than 20. Hey, that works too. So we have a green dot here at 0 as well. My point here is that numbers, it appears like numbers to the right of negative 5 will work. So let's go ahead and try another number over here on the left of negative 5. Let's see if negative 10 works. If I substitute negative 10 in, we would have negative 4 times negative 10. Is that less than 20? And well, you've probably already figured it out. That would give me positive 40. 40 is not less than 20, so that one doesn't work as well. So that's very, very not true. That's not even a nice statement, but you get the idea. So let's talk about the math behind why this is not working. Remember, we need something less than 20. We need numbers smaller than 20. So numbers multiplied to negative 4 have to be something that comes out smaller than 20. And so it appears that anything to the right of negative 5 is true. Anything here multiplied to a negative anything there is going to work. Now, why? Why is that true? Well, it's because we multiplied by a negative 4. So we make everything negative when we put numbers in. It changes the sign of the number. And so because of that, we can solve this inequality as follows. Negative 4 times x is less than 20 can be divided by negative 4, just like a normal solving an equation, divide by -4, but when we divide, we also have to flip the inequality over in the next statement. So here on the next row, we will write x is greater than -5, because remember, we divided by a negative, so it's anything to the right of -5. And here is another really cool thing about inequalities. If you solve for x on the left, it reads nicely that way, x is greater than -5. That sounds so, in my brain, that makes sense. Notice that this inequality is pointing the direction you would plot. And so I can write this in several different ways, just like from the last video, but I'm just going to go ahead and write it as an open dot at -5 and moving to the right. This will make that statement true. Also, for interval notation, I can write this as open paren -5, or comma, infinity, close parenthesis. As you can see here, I've provided another number line. This is for you to do a trial run on your own, just kind of like I did over here, with different values to the left and right of the number that we were curious about, which was the -5. So I would encourage you to take notes on why this works. Go ahead and think about what happens when you multiply or divide by a negative number. It always changes the sign of the number on the other side of the inequality, and how that will affect your direction of your inequalities. And then we'll move on to the next video.